warm-up. Today's warm-up. What do you notice? What do you wonder? Take a look, see what you guys are noticing and wondering. Think about what have you guys been doing in the past 2 weeks. You guys want to do it? I know you guys have the library. Okay? Think about what we have been doing. How can you apply that? All right, we're all familiar with the parking lot. What do we notice? Any patterns? Any colors? Have somebody type what we've been learning? Okay. What fraction of the cards are blue? And what fractions of the cards are white? Okay. Let's talk in your tables. What do you guys notice now? Now we're trying to apply and see fraction of the cards are blue and what fractions of the cards are white. Go ahead and turn to your tables. Let's see if we can come up with any fractions. It looks like the image is an aerial photo, right? What does that mean? The photo was taken from where? What perspective? Aerial. Okay. So with that being said, it's a parking lot, right? We're all familiar with the parking lot. With that being said, now, are we gonna be able to get the exact number, the exact data? Not really, right? So we can go ahead and just estimate, right? Does that make sense? Yes? Yeah. Okay. Go ahead and talk to your tables. See what fraction you guys can come up with. Blue cars, white cars. Go ahead. I'll give you guys 1 to 2 minutes. Like, just by seeing it, like, those cars and how can you apply it, like, okay, and we're focusing on what cars are blue, and then what fraction of the cars are white. How can we? Okay, you're 1/8 there, right? So remember, it's an estimation. We can't have like the exact number, right? Because the photo was taken. Okay. In your table, so we can come up with 4, 6. Okay. So which one do you need more white cars or more blue cars? More white cars. So you need a fraction of white cars.
Because there's also 1/4 of there's 1/4 of red, but there's that one yellow card. That one yellow card mixes with the numbers.
Alright, pop it over. What do you guys think?
I guess like 2/16 maybe, 1/8, and 2/16. Yeah. That makes sense.
1/10
3/4 plus 1/8 plus 2/16 equals 1. So 1/2 would be white cars. 1/4 would be blue.
Okay, can anybody share what you guys shared at your tables?
Would be
What fractions of the cars are blue? And what fractions of the cars are white? Remember, it's an estimation. Anybody would like to share? Can we look at maybe rows by rows? But 1/4 of the cars are white. Okay, and how did you come up with 1/4? Yes, I agree. So there's more white than blue. Do we see that? So Frida's saying 1/4 of fraction would be white. Do we agree? Do you have a different number? What about for blue? Is there less blue? Less blue cars? Lilith, an idea?
What I was thinking for the white cars, I'm gonna see a half, because what I'm seeing is there more, like at the edge.
Okay.
For blue, we said 1/4.
You're saying 1/4, okay.
For blue.
Okay.
And then I said 1/8 for red, because there are red cars.
Okay. So you're saying for the white again is about how much?
A half.
A half? And Frida is saying about 1/4. Okay. What do you guys think? Can we meet in the middle? How can we come up with a fraction? Do you think there's about 20 cars in each row that are white?
most of them are white.
Yeah.
Most of them are
Okay, so I think the fraction could be between, like what Frida was saying, Lilith, right? 1/4 and 1/2. And then the fraction for the blue cars, it needs to be what? The denominator would be what? Larger or smaller? What is it again? Larger, right? So what can we say? 1/6, 1/8, 1/10. look at more examples. Okay, so I'm gonna have you guys tables 3 and 4 return back to your seat. Are you guys taking out any books? Yeah, we have that one. Okay. Good. You wanna take that one out? So 2 weeks from today would be the 20th and 28th. That's what it's gonna be, 10, 28th. So we're gonna be looking at, we're gonna be writing equations and we're gonna be drawing diagrams, okay? That's what we're gonna be working on today. In your math journals, I'm gonna have one person from each table go ahead and grab your boxes, please. We're gonna get our math journals out.
Wait a minute, you wanna look at the box? Okay. Just get 4.
I should get 5 just for extra. That's 6.
Okay, so if you guys can go to your table of contents. And we're gonna put learning objective for title. And today's date, October 4th. Table of contents, go ahead and add your title and today's date, October 14th.
We don't have a table context in this one.
Oh, not for this one? Okay, let's just go to a clean page. Clean page. And for the title, we're gonna put learning objective and today's date. So remember for the learning objective, you have it right over here on the board. We're gonna find part of a part or determine how much a fraction of a fraction is. Or we can write equations and dot diagrams. Okay, looks like most of you guys are done with your learning objective. So first step, it's asking us to draw a rectangle, right? And we're gonna label it what? B. We're gonna label it B. Then it's asking us to partition it into thirds going one direction. Okay, so we're gonna go vertical into thirds. And I'm gonna go ahead and label it. And what am I missing? I need to shade 2/3 and label it 2/3. What's the next step? We're gonna partition the rectangle into fourths the opposite direction. What would be the opposite direction again? Horizontal. fourths, correct?
Yes.
And we are gonna go ahead and shade 1/4. 1/4. What's the next step that's asking us to do? We're gonna write an equation to represent the diagram. Most of us are about to be done with our equation. Can someone share what they have, what they put down as their equation, Elisa?
My equation, I put down 1/4 times 2/3 equals 2/12.
Okay, Elisa has, do you repeat it again, Elisa?
1/4 times 2/3.
And that gives you,
2/12.
where is the double shading happening? Do we see that it's happening up here? Shaded twice? Right? So this one right here is 1/12, and then this one right here is 1/12, correct? So it's 2/12. Do we see that? Did somebody else do it differently? So, yes, Elise? So Elias did 2/3 times what again, Elias?
1/4 times 2/3.
You did 1/4 times 2/3?
2/3 times 1/4.
2/3 times 1/4. And that gave you, when you multiply it across, that gave you what, Elias? Is that the same answer? Yes. Leonard?
You can also say instead of 2/12, you can also say 1/6.
Okay, so what do we call that? What did you do there?
Basically, since you divide 12 by 2, and then you get 6, and then you divide 2 by 2, and then you get 1.
So you simplified it? So you said, you can also say it what way again? Instead of 2/12? 1/6.
You can count them. You can count them. The 2/12s
Uh-huh.
there.
Yes.
Then you can add another that's 2/6. Then you can add another that's 3. Then you can add another that's 4. Then you can add another and that's 5. And then for the last 2, that's 6.
Do we all see what it is saying? Yes? We're gonna be doing our first activity. We're gonna be doing first one together, and then we're gonna work in pairs. Okay? We're gonna work with a partner. Yeah, I'm gonna put them.
Table phone?
Uh,
A partner from our table, or you need to pick a partner from the class?
I'll let you know. Okay. So we're gonna write a multiplication expression that represents the shaded region in each diagram. Okay? Can someone help us out? What's the first step? What's the first step for A? If we're looking vertically, What was it partitioned into? Can someone raise their hand and let us know? Anissa? Into fits. Do we see that? 2, 3, 5, so it's into fits, correct? How many shaded? Sorry. Said 2 fits? And the opposite way. Horizontally, what? Diego? And 2/3. Do we see that? Okay, I won't call it. And then you said 1/3? Do we see the 1/3? It's at the top, I just couldn't reach. Yes? So what expression can't we make to represent the shaded region? Mia? 2 fifths times 1/3. And when we multiply across, we get what? Get it? Do you see something? Did you do it differently? Can we also say, I'm gonna do it down here. It was partitioned into 1, 5, and then this one was shaded. 2 fifths, 2/3. Can we say can we see it this way also? Right, when we add them together, it's the same as yes. Try and do B at your tables. Column B. So let's see how they partition it vertically and then horizontally. Do we see that for A? We can also say 2 times 1/15. 2 times 1/15. Do we see that? Yes?
Yeah.
Yes, right, because we have them right here. 1, 2. Both ways are correct. Are you guys done with B? Okay, what did you guys hear? Someone tell us what you guys did at your table to B. Catalina? You did 3 fifths So you did 3/5. Wait, I'm just gonna write right here. Times what again? Did anybody else get something different? Are we noticing any patterns, Karen?
I noticed like that something don't move the diagram, and you can see equation that was part of the denominator and what's part of the numerator.
Yes. We can do it with or without. That's a good observation. Anybody else notice like a pattern of what's going on? The shading part?
I noticed that on the last equation it was 2/5, and now on the next one it's 3/5, and on the last one it was 2/15, now it's 3/5.
So what's happening to our numerator and denominator? So if you think for the next one, the numerator would be 4/5, maybe? Did anybody else notice anything different? A different pattern? Do we see a different pattern? Okay, before I break you guys out into, with your partners, can we see that? Can we all see that? Can we see the part? So we can use an area model to show the product of two fractions. This is what we've been doing, okay? So we have here, for example, 2/3 times 1/4, right? It looks here in this diagram that they partition it vertically. 1/4. Remember, we can partition, it doesn't matter the order, right? So they went 1/4, they shaded the 1/4. Are we here, Catalina? And then the opposite way, they did 2/3. So we divide our model into 4 equal parts and shade the 1/4. Then we divide our model into thirds, going the opposite direction, and shade 2/3 of it, right? We're shading the 2/3 from the original shaded part. Do we see that? Then we go ahead and we count the number of parts that are shaded twice. And when we do that, we get 2/12. So now we have 2 of 12 parts shaded twice. I'm gonna leave this up here so that it can help us with our activity, okay? Then I'm gonna have this also up here as a refresher. So exactly what is a fraction, a numerator, a denominator? I know you guys know. Okay, so if we turn our paper over, I'm gonna sit you guys with partners, okay? I'm gonna have Keren work over here at this table with Lilith and Anissa. And I'm gonna have Diego. Actually, I'm gonna have Elias come over here and work with table 3. Okay. So it'll be Elias and Mia, and then it'll be Diego and Paloma. Darian. Darian and
Did she give us one?
Okay, you're gonna be working with Lynn and then you two together. You two together.
They have the same thing.
Okay, then you two together.
I have version C, so I have version D. Version D.
It's the same thing.
Version C. Version C.
Okay. So now you guys can go ahead and turn your page over and work. Yeah, that's fine. How are we doing here?
We're gonna try and do that. We're gonna try and do
That's the challenger, yeah, that's the last one is the challenger. Okay. Ooh, nice. A lot of them are, okay, double check on our expressions.
I found an estimation.
You did?
Yeah, I have this in the grade and you already know where you can go.
Okay, crosses of elimination. Now what do I do?
The fraction.
What about you? What did you get? A, C, and D. And Darian? A, C, T, and E as well. And how did you guys figure out? Okay, so we're doing that one. The diagram says the equation because 6 is the answer Okay. Okay, so we still have to work on that one, and then that one. Okay, so we're gonna go over this. Okay, from process of elimination, can someone share what could be one of the possible answers for this diagram?
I stole my sister's sticker.
Unit? I need your attention up here to A, which is 4/5 times 1/3. Do we all agree?
Yes.
Yes?
Yes.
Do we see that?
Yes.
1, 2, 3, 4, 5. So that would be our what? And it's shaded, right? 4/5 times 1/3, and we can see they went the opposite way into thirds, and they shaded the top, correct? So that expression works, A. So let's all circle A if you don't have it on your worksheet. What's another possible one, Anissa?
E.
E. 4/15. Do we agree?
Yes.
Can someone explain that one? Leah?
It's like the fraction. The whole fraction.
Uh-huh.
If you do 4/5 times 1/3, you get 4/15.
So that one would work, correct? So let's go ahead and circle E as well. If you don't have it, circle E if you don't have it. Another possible one. Oh, yes? D. Do we all see that? D. So can you go ahead, Elias, and explain why? So 4. Ah, okay. So each one of these ones is one what? so it's 115? And you multiply it times 4 because there's 4 of them, right? Do we see that? Israel, eyes up here. Do we see that?
Yes.
That there's 4 1/15. So that could be our answer too, right? D. Go ahead and circle it on your worksheet if you do not have that one. Anything else? Leonid.
C.
C. 4 times 1/5 times 1/3. Can you explain that one to us?
Basically, just like multiply 4 times 1/5, and you get 4/5, and then you'll get the same equation as
So you did for 4 times 1/5?
Yeah.
Did you put a what other? Yeah? So then you got what?
About 4. And then it's usually the same expression. We already discussed that.
Did anybody else get the same one as Leonel? Will that one work? What do you guys think, Jen and Lilith? You're saying that C would also work.
Yeah, good word. Yes.
Let's go ahead and circle it in our worksheet if you don't have that. Okay, let's go ahead and put our names. If we're not done, it's okay, we're gonna continue with this. So lesson synthesis, can we look up? Can someone read the screen? Paloma?
Dang it.
You should be able to show your thinking with diagrams and various expressions. That's what we did today, right? You can do more than one. So we are gonna get ready to do cool down, okay? Wanna see what you guys have learned so far. This will help me know what we need to review a little bit more. So as soon as you get it, go ahead and put